Welcome back to Geometry. This is section 2.5. We're going to be making more proofs and showing you how to do it. And we're going to prove things about line segments, and we're going to make statements about that. Okay, so first to review, we have three really important ideas that we will apply to different situations. The first one is reflexive, because you're seeing yourself, and the reflexive property is if you had a line segment AB, it equals itself, AB. Just like you see your reflection in the mirror, AB sees its reflection in the mirror. And that symbol is congruent. Now in geometry, we have equals and we have congruent, and it's a little bit etiquette when you use which one. And eventually I think you'll get the hang of it. We'll go into it more later. Okay? The next one is the symmetric property. Just like my hands are symmetric, but they're opposite from each other. You can't put them on top. The symmetric property is applied to line segments. If line segment AB is congruent to CD, then CD is congruent to AB. And remember, congruent means equals, basically, same length. Okay? The next one is transitive. And transitive is if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Transitive property. All right? So that's just a review of that. And now I'm going to show you a proof. The proof is in your book, if you're following along, on page 103, and it says, use the diagram and the given statements to complete the missing steps in the proof. Given LK equals 5, JK equals 5, and JK is congruent to JL. Now, whenever you're given a proof, the first thing you do is you can write all the givens. Now, sometimes people will break up the givens and put them later down the proof. It's not wrong, though, to go ahead and list those. So here are the givens. And I like to have a drawing with every proof. If you can draw it, draw it. It's going to make it easier. And what we're supposed to prove goes down here. They want us to prove that LK is congruent to JL. So let's sort of break it down. First of all, on our drawing, LK equals 5. So I like to go ahead and label it. JK also equals 5. And JK is congruent to JL. And how you show that is you draw one line through both of them. And that says that those are congruent. In your book, a lot of times those lines will be red, but I just have my black marker out. Okay? So those are my givens written on my drawing. Your drawing also counts as a given, and sometimes they'll just give you the drawing and you figure out what it's saying and list them down. Okay, the next thing we can say is that LK is equal to JK because they're both equal to 5. LK equals 5 and 5 equals JK, so we can say that LK equals JK. I should have held my hand like that. Do y'all get it? Okay, they're both equal to 5. That one's 5. These are our line segments. And we can say they're equal to each other by the transitive property. The next one is, once we say they're equal, then we can say they're congruent, because that's the definition of congruence. Things are congruent if they're equal. Why do we do this? That's the haiku of poetry part. That we wanted to change from equal, see how those were equals, to congruent, because what we're proving is congruent. Okay? And then what we're trying to prove is that LK is congruent to JL, and we can do that by the transitive property because they are both congruent to JK. That we've shown that both of these, JK is congruent to JL and JK is congruent to LK. So we can say that they're congruent to each other. Let me say it for you. JK, no, I should do it the other way. Yeah, no, I can do it that way. Well, I'll do it, yeah. LK is congruent to JK and JK is congruent to JL. So LK is congruent to JL. All right, this will get easier, I promise. Okay, let's do another one. This one we have, it says, in the diagram, Q is the midpoint of PR. Show that PQ and QR are equal to 1/2 PR. So here's our drawing. So our given was Q is the midpoint of PR. And what we're trying to prove is this formula. QR is equal to 1/2 PR, the whole thing. Okay, so the first thing we can do is we can say that PQ equals QR by the definition of midpoint. And you should have learned midpoint in Algebra 1. Midpoint is just the middle part of a line. But if you didn't learn it, today's a good day to learn it. Alright, so now we've got PQ equals QR by definition of midpoint. Now, we can say that PQ plus QR equals PR, and we're allowed to say that by the segment addition postulate. You're allowed to add up segments that are next to each other. Then we could say that PQ plus PQ equals PR by substitution. Because we said that QR equals PQ, we can substitute it in. But if we do, we should sing the song first. Substitute. Okay, now we're ready. Now, the next thing we want to do is PQ plus PQ is 2PQ. We're allowed to do it. They said because of the distributive property, they're doing like distributive property in reverse. I think a better reason for this is simplification. Remember, we learned that we were allowed to add up those x's, and they said simplification was the reason. So once again, there's lots of ways to be wrong, but there's also more than one way to be right on these proofs. Okay, so now, why is PQ not alone? It's being multiplied by 2. So we want to move that to the other side. So we're going to do the opposite and divide both sides by PQ, by 2, which will leave PQ by itself. And remember, dividing by 2 is the same thing as multiplying by 1/2. So we could do divide by 2, divide by 2, and that's the same thing as multiplying by 1/2. So now we have PQ equals 1/2 PR, and we've already shown that PQ equals QR, so we can substitute it in. PQ equals QR. We can substitute it here after we sing the song, substitute, and then we have what we were supposed to prove. QR equals 1/2 PR. Alright, so that is it for section 2.5, just showing you some more proofs. The other thing is you'll have a drawing lab. You'll use your compass, it's that thing. Here's mine. Here's one. I used to have a big one for my chalkboard. Okay, and how you copy a line segment with your compass is you put your pencil on one end, you put you put the pointy thing on one end, you take your pencil and you draw and you measure how far it would be to make a swoosh line. Then you put the pointy thing, you draw a line and put a dot here, put the pointy thing there and you draw a swish. And that swish should be the same length, and then you put a point where the swoosh crosses the line. Look at it in the tan box in your book, and you'll be doing that for a drawing lab. Take a picture of it and send it to me for credit. All right, math is fun. See you later.